So the aviation industry produces 12% of all carbon emissions in the transport sector and can produce up to 3 times as many carbon emissions per mile than a conventional petrol car. So it's not surprising that there's been a lot of focus into how these emissions can be reduced, the most notable of which being electric flight. However, there are still a few challenges to fully commercialise long-haul electric flight. For the most part, these electric planes use propellers or electric ducted fans, which produce more thrust for a given size, and this is because they have fewer tip losses. These losses come from the formation of vortices at the end of a blade that cause resistance to the spinning propeller. These form due to differences in pressure above and below the blade. However, in a ducted fan, there's not enough room for these vortices to form. Additionally, all the airflow is forced into the desired direction. However, ducted fans don't come without extra weight and drag caused by the housing, though the thrust from these electrical systems is nothing compared to that of a conventional jet, where air is drawn into the system, compressed, combined with jet fuel and ignited. As the air and fuel mixture ignites, it heats up and expands, creating a high velocity jet which is shot out of the back, subsequently turning a turbine. This is quite an oversimplification, but I'll leave a link to a video below that goes into some more detail if you're interested. So how can electrically propelled aircraft reach the level of thrust achieved by a conventional jet engine? Well, a team of researchers from Wuhan University think they may have found a possible solution. This jet utilises ionized air plasma induced by microwaves to convert electricity into thrust. This is not to be confused with ion thrusters that shoot out positively charged ions of a gas such as xenon. As a side note, ions are either positively or negatively charged atoms that have either gained or lost one or more electrons. Here, in this ion thruster, the xenon gas is ionized by knocking out an electron using other electrons in the ionization chamber. These positive ions are attracted to a negatively charged grid and shot out of the back at incredibly high speeds. As they shoot out the back, an electron is also reintroduced to neutralize the ion and preventing it from being attracted back to the thruster. This is an invention straight out of science fiction, however it produces only a tiny amount of thrust and cannot even overcome the friction of Earth's atmosphere, let alone propel a commercial plane. Though in the vacuum of space this is not an issue, and over time the tiny amount of thrust compounds to enough force to move a whole spaceship. But I digress, how does this new plasma jet work? Well, instead of xenon gas, it uses air around it, and much like current fuel jets, it compresses the air before heating it up so it can expand out of the back to create increased thrust. Where it gets interesting is when we look at how the air is heated, and to understand this, it is useful to first look at lightning. So plasma is a gas of ions and free electrons, and plasma is the fourth state of matter alongside solid, liquid and gas. It is also thought to be the most abundant state of matter in the universe. Plasma is formed when the gas is provided with enough energy to free an electron and turn the atoms into ions. This is commonly achieved with high temperatures, such as in the sun, or high electrical fields, such as lightning. What this means is, lightning turns the air around it into plasma, and because the plasma is conductive, it allows the lightning bolt to continue its path. In this electric jet, instead of high electrical fields or high temperatures, concentrated microwaves are used to provide the energy to the compressed air to ionize it. This ionized air is ignited with an electrical spark that causes the now conductive air plasma to heat up, much like the air plasma around lightning. This air plasma reaches over 1000 degrees Celsius and expands into the tube to create thrust out of the back. The scientists that discovered this found it produces a similar amount of thrust to a combustion jet engine per square meter. However, this is a laboratory scaled experiment, so it is unlikely to be this effective when scaled up. The scientists found that when running a 400 watt jet engine, they got 11 newtons of thrust, with 4 newtons of that coming purely from the compressed air, which equals around 28 newtons per kilowatt. However, this was at a faster air flow rate, and at this flow rate there were no tests for higher powered microwaves, causing questions about how this might scale, but we'll work with what they've provided. With a Tesla Model S battery pack running at 310 kilowatts, This creates a thrust of 8,500 newtons. Using the thrust-to-weight ratio of a large commercial plane, like the 737, which is about 0.3, it means that if this was scaled up, the electric jet could fly a plane of approximately 3 tons, which, given the weight of a battery pack for the Tesla Model S weighs about half a ton, leaves 2.5 tons for, well, everything else a plane needs. Obviously, this is in its infancy, and the energy density of batteries means that this hypothetical flight might still be short-lived, but it is an interesting development nonetheless. Additionally, this power consumption doesn't seem to include the power required to compress the air. Although these limitations may seem disheartening, maybe there will be more breakthroughs that take this idea to a commercial level. Only time will tell. Looking back over 100 years to the Wright brothers' first 12-second long flight, it is hard to believe where we are now. Who knows, maybe this electric jet technology could power the rockets of the future and take us to colonize Mars. Either way, I hope you enjoyed this video, and leave a like if you learnt something new. Make sure to subscribe for more content within the world of sustainable technology and business. I've left a link to the paper and some other informative videos below, and I'll see you next time.